Yeah, good day all, and like we have a brown problem here, and this problem you can see it as if it is difficult or tough, but it's one of the most simplest problems I've ever come across that involves problems given in this form, and it's very simple and straightforward. But like along the way, you can see how it looks like, and just after the video you can even take less than 5 minutes or 4 minutes to work out this problem. By the way, you can see it as if it is difficult, but it's very simple. You see, we are required to find the derivative of this function, that the first derivative of this function, and the function is given as x raised to power x raised to power 2x plus 1. So it involves three powers. You see, it involves three powers where you are required to find the derivative of this problem. So it's very simple and straightforward, as I was saying, and let's see what we are going to have. So in this case, the first point, I think the easiest way, we let the function to be y or f of x, and we equate the function to be equals to this. That's the first point. And the second point, you can as well go in, we try to take lane on both sides. After taking lane on both sides, and we can now go differentiate, and we see what we are going to have at the end of the day. Like I was saying, it's a very simple and straightforward question, but it's very tricky again. It's very, very tricky. So if you don't take your time, you slightly move away from the normal steps you're supposed to have. So let's see what we are going to have. Like I was saying, the first step, we'll let the function to be this. Either we'll let y to be equals to this, or we'll let the function f to be equals to what is given here as the original function. That's going to be our first step. So the next step again, we'll try to take lane on both sides and that. So let's see what we're going to have. Let's say solution. So we let's f of x to be equal to this function x raised to power 2x plus 1. This is what is given to us. You see, so now we cannot differentiate this directly as this, because here we cannot say we can use the product rule, or we use the quotient rule, you see, or we use the implicit function rule. You see, so the most comfortable method I think we can use here, we try to take lane on both sides first, at least to us to reduce the powers given, because here we have two powers. We have the first power x, and we also have the second power, which is given as 3x plus 1. So I think we can take lane on both sides for us to reduce the powers, you see. And the next point again, we can see what's going to be the next point. We can now differentiate the function as required. So to reduce these two powers, so take lane on both sides. So if we take lane on both sides, say lane of f of x is going to be lane of x raised to power 2x plus 1. So there is it. So since we introduced lane both on the left and on the right, so the next point, you take this power, we bring it to the coefficient of this lane function. So if we do that, we have lane f of x equals to, if we move this, is going to be x raised to power 2x plus 1. And what remains there is lane of x. I think now it's very simple to differentiate, to find the derivative of this function given. So now we can differentiate on both sides, we differentiate it. But we can say again, we also have another power here. So this exponential, we need to consider it separately. You see. So if we consider it separately, let's say we call this an asterisk. We are not yet done on that. Let's consider this one separately. We say let y equals to, let's differentiate this again, x to the power 2x plus 1. Let's see what we are going to have when differentiate this. So if we differentiate this, what we are going to have is what we are going to consider now. I think we use that one, we consider the original function here, and we differentiate for us to have a simple result. Because like if we say we differentiate, because here it involves a product rule, because we have this x as a product rule with its power, and also have ln x as also a product rule, you see. So if these values represent the product rule here, which we are going to use, so if we keep this constant, we differentiate this value, and as well as we can also keep this constant and we differentiate it. So in an easy way, let's differentiate it separately, the results we are going to have. So when we come to the original function given, we know that the differential of this x over 2x plus 1 will give us a particular result. So what is that result is what we are going to find. So we carefully let this function to be y. So differentiate y with respect to this. So in this case again, this also involves with power. In most cases, when you come across these functions that involve with power, so you need to take your time. You see, the easiest way, just introduce ln on both sides. The power given, you move it to the coefficient of the function given, so that you can easily differentiate. So if we do that, we introduce ln on both sides again. Ln y equals to ln x raised to the power 2x plus 1. This is it. So we can also move this. So if we move it, we have ln y equals to 2x plus 1, and we have ln x. This is it. So if we differentiate this function, differentiate ln y, anytime you differentiate ln of this y value, it's always going to be 1 upon y, 1 upon this function. And if you differentiate ln y, now it's going to be dy all over dx. Here we have these two products. We can say we keep 2x plus 1 constant. So keep this constant. We differentiate ln x, which is 1 upon x, plus, since here we try to keep this constant, we differentiate this. Now we are going to keep ln x constant to differentiate the bracket. So if we keep ln x constant, we differentiate the bracket. So if we differentiate 2x is 2, plus we differentiate 1 is 0. So this is what we have. So if we roll on that, so the results will look like 1 upon y dy dx equals to 1 upon y dy dx equals to 2x plus 1 divided by x, because this time this is this, plus, and ln x time, because 2 plus 0 is 2, 2 times this will just going to give us 2 ln x. This is it. But don't forget, and we have the y here, we can multiply this y, so dy all over dx is going to be y times this, because this y will multiply these two terms. So it's going to be y into 2x plus 1 divided by x, plus y again will multiply by this is going to be 2y in x. This is what we have. So if we move again, dy all over dx, we're going to be this x, we can move it up. But what is y? We have y to be this value. So we substitute it as x raised to the power 2x plus 1, because this value of y is this. And this x, we can move it up again times x to the power minus 1, because this x to the power is 1. When we move it up, it's going to be negative, and we'll maintain the bracket, which is 2x plus 1. Plus 2y, y again the same as this, and we rewrite that x raised to the power 2x plus 1, and we maintain our ln x. This is all what we have. So we can combine, we can further simplify it. So if we simplify in indices, like when you multiply the same base, you see, and you can carefully add or subtract the powers. So we take x, so 2x, this is going to be 2x plus 1, and we have minus 1 here. We maintain our bracket, which is 2x plus 1, plus 2x raised to the power 2x plus 1 ln x. So plus 1 minus 1 will cancel out. So therefore, dy all over dx is going to be x raised to the power 2x into 2x plus 1, and plus this will still be 2x raised to the power 2x plus 1 ln x. So this is what we have. So in this case, since we are differentiating this function, now the derivative of x raised to the power 2x plus 1 is this. So when we differentiate this is what we are going to have. And also if we differentiate ln x, we are going to have, as we did it here, which is 1 upon x. So that's it. So the differential of x over 2x plus 1, its derivative, its first derivative is this value. You see, this is what we are going to have. So after having this now, so we can continue with this function, because we are required to find the derivative of this. So we continue from this point, from this relation. We say ln of f of x equals to x raised to the power 2x plus 1. Let's keep that, and ln x. So if we differentiate ln of this function, it's going to be ln of the function. It's going to be 1 upon f of the function multiplied by the first derivative of the function. This is it. So differentiate ln of f of x is going to be 1 upon this f of x and the first derivative of this function equals to, if we keep ln x constant, let's say we keep ln x constant, and if we differentiate this term, which is x equal to 2x plus 1, its differential is this. So it's going to be this value. which we are going to substitute. Let's say it's going to be x raised to the power 2x, down is 2x plus 1, plus, and we also have 2x raised to the power 2x plus 1, and ln x. This is what we have. You see, plus, we are not yet done. We know we keep ln x constant, we differentiate this value. Now we are going to keep this value constant, we differentiate ln x. So if we keep this value constant, x to the power 2x plus 1, and if we differentiate ln x, we just 1 upon x. This is what we have. You see, so now we can just simplify the function. We can simplify the function. So if we simplify the function, let's see what we are going to have. So if we simplify this function, you know this f of x, we can cross multiply, so this is going to be f of x prime equals to this f of x will multiply by this, going to be f of x multiplied by the whole of this function, because this ln of f can multiply by this ln x times this value, just going to be ln x. And if we multiply it by this, let's start writing this bracket. Let's say we write 2x plus 1 and write our ln x and write our power, which is x over 2x plus this ln x again times this value, just going to be 2 ln x. Or let's start with the power 2x raised to the power 2x plus 1. Don't forget, we are multiplying ln x times this value, which is this, and we also multiply ln x times this other value. So ln x times this, so we write 2x by x plus 1, and ln x times ln x, we're just going to give us ln x all squared, that it is it, plus this x will move up, because this 1 upon x going to be 2x plus 1 times this x is going to be minus 1. This is what we have. You see? Yeah, this one we have, but all multiplied by, because this f of x will multiply all these three functions. You see, this ln x will only multiply these two functions, ln x times this, as we have here, and this ln x will also multiply these two functions, these two product functions, this and this. You have this here, plus x, this x1 upon x same as x over minus 1, so x over minus 1 times this will give us this. So this whole function will multiply by this f of x, which we have as this. But mind you, f of x, we let it to be this function. You see, we let it to be this function. I think we can use this space. So if we use this space, so we continue. So if we continue at this space, at this point, we continue, we say f prime of x, which we are required to find. And we have this f of x. This f of x, we have it to be this. So it's going to be x raised to power x raised to power 2x plus 1. Bracket open, we write, and this, we write this value, which is 2x plus 1. And we have x raised to the power 2x. And we have our ln x plus, we also have this value, which is 2x raised to the power 2x plus 1, and we have our ln x all square, let's see, plus, we also have our final value, x, because these terms here, let's look at them. X is the base, x here is the base, so take one base, we add a power, so plus 1 minus 1 is minus 1, it's just going to be x to the power 2x. This value is just going to be x raised to the power 2x. This is this. So we have three terms. We have this term, we have the second term, and we have the third term. So we can multiply this throughout by those functions. So f prime of x going to be this time this. This will just be like 2x plus 1. And we have our x raised to the power x, 2x plus 1. And we also have times multiplied by x to the power 2x. And we have our ln x. So multiply this time this first three times, we have this, plus we also multiply this term multiplied by this second value, so it's going to be 2x to the power 2x plus 1 times this value again, which is x to the power x to the power 2x plus 1, and we also have its ln x all squared plus, think we can plus, I think we can continue here. We can just clear this here. We can clear this point. So if we continue plus, we multiply this time, this give us this terms. We have a plus sign, multiply this time, this again will give us this. Plus, now take this term, multiply by this last value. So it's going to be x raised to the power x, which is 2x plus 1, and multiply by this value, which is x to the power 2x. This is what we have. I think we are done. We can stop here, but we can further simplify these terms. So we simplify, so this derivative of x, so say 2x plus 1, x to the power, because this and this, they are the same, we can take one base, we add their power. So it's going to be x plus this 2x. But this first x is having a power, which is 2x plus 1, so we can write it first, x to the power 2x plus 1. But this x will sum this x and this x, they are the same. We take 1, we add this value raised to the power 2x plus 1 plus this value, which is 2x. So we are done with that. But don't forget, we have our ln x, which is ln x, plus we also consider this again. This again, let's say we have our 2, we take x again, we take x, we add them again, it's going to be x raised to the power, because we have this x, we take one of this x, we add 2x plus 1 plus this, so it's going to be x to the power x, 2x plus 1 plus, we also add its power, which is 2x plus 1, this is it. But don't forget, we also have the square of the linear, which is ln x all squared, plus, I think we are done with this. We also take the last term, which is x raised to power, because, again, this and this, they are the same. We take 1 as this, so we add the power. The power for this is x to the power 2x plus 1, and the power for this is 2x. So we'll add this power, and also plus this power. So it's going to be x to the power 2x plus 1 as the first power, plus, and we'll add the second power, 2x. So this is the final result. This is the final derivative of this function. Or let's maybe over to further write it in simple form, but I think this is the most easiest way of writing it. Starting with the ln, you can say f of x prime is going to be 2x plus 1, and we write the ln first, and we write the power. I'll start by the x value. So the x value is this, x raised to the power, let's say 2x plus 1, and we have our x value, which is x to the power 2x plus 1 plus its power 2x in x. I think it can be written this way. We start with 2, we have our ln x squared, and we write our x value, x to the power x to the power 2x plus 1 plus this other power 2x, and we take the last value, which is x to the power x with its power 2x plus 1 plus 2x. I think this is the easiest way we can summarize this. So this is how we arrive to this point. You can see it, you can solve this for less than 5 minutes. You see, it's somehow simple but tricky. So this is how we differentiate the length function. So the derivative of this function, x to the power x raised to the power 2x plus 1, will be equals to this function. Mind you, this f prime of x is the same as the first derivative of this function. So thank you. Stay good.